let's cover all the exponent rules or laws of indices that you should know. First, let's say that a and b are constants where both a and b do not equal 0 and x and y are variables. The first rule that I'm going to cover is the product rule. Let's say that we have a to the power of x and a to the power of y, so we have the same base of a. Also, the results of raising a to the power of x and y are being multiplied. We can rewrite all of this as a to the power of x plus y. So, we're keeping the same base of a, but the exponent becomes the sum of the original exponents. The next rule that you should know is the quotient rule. Let's say that we have a to the power of x and a to the power of y again, but they're being divided. We can rewrite this as a to the power of x minus y. So, we're keeping the same base of a, but the exponents are being subtracted. The x comes from the exponent in the numerator and the y comes from the exponent in the denominator. The third rule that you should know is the power rule. If we have a base being raised to a power inside parentheses, so let's say that we have a to the power of x, and on the outside we have an exponent, so here we have y, we can just rewrite this as the base being raised to the product of the exponents. So here we're going to have a to the power of x times y. Another rule that you should know is the power of a product rule. If we have multiple things being multiplied inside parentheses, such as the constants a and b, and on the outside of the parentheses we have an exponent such as x, we can just bring the exponent down to the things that we're multiplying. So here, we're going to have a to the power of x times b to the power of x. The fifth rule that you should know is the power of a fraction rule. If we have a fraction being raised to an exponent, such as a over b to the power of x, we can just bring the exponent down to the numerator and denominator. So here, we're going to have a to the power of x over b to the power of x. Now, I'm going to cover zero exponents. Whenever you raise something, such as a to the power of 0, the result will always be 1. However, keep in mind that a cannot equal 0. The reason for this is that if you raise 0 to the power of 0, the result will be undefined. So, you cannot raise 0 to the power of 0. Two situations can occur when you have negative exponents. First, you can have something like a to the power of negative x. This is the same thing as 1 over a to the power of x. Also, you can have something like 1 over a to the power of negative x. This is the same thing as a to the power of x. Next, I'm going to cover fractional exponents. If we have something like a to the power of x over y, y is called the root and x is called the exponent. A to the power of x over y would be the same thing as the y root of a to the power of x. This is the same thing as the y root of a, and then the exponent of x is on the outside. As you can see, x is the exponent and y is the root. Lastly, let's do an example which involves some of the things that I covered. We have to simplify this expression. 3 to the power of 0 is just going to be 1. I could multiply 2 by 10, but I'm just going to bring the exponent of 2 down to 2 and 10 using the power of a product rule. So, we're going to have 2 squared times 10 squared. In the denominator, we have 1 over 5 to the power of negative 2, which is the same thing as 5 squared. 2 squared is 4, 10 squared is 100, and 5 squared is 25. 4 times 100 is just 400. And 400 over 25 is just 16. 16 squared is 256. Lastly, 1 plus 256 is 257. So, 257 must be the result.